Let's look at how to calculate percentile ranks and areas underneath the normal curve. So to do this, we are going to go back to our five friends, the five girls who have who are named after places in France, who sit around uh, eating different foods and talking about what they're eating. Well, here we have Brittany, Lorraine, Rochelle, Brie, and Paris. They are at a Mexican restaurant, Taco King, and they are sitting there eating chips, and they notice that each of them tend to eat a different number. Brittany usually eats 0 chips. Lorraine has 3. Rochelle eats 8. Brie 11. And Paris 22. Now they're wondering how that compares to everybody else in the world, or at least everybody else who eats at Taco King. And so they decide to ask a lady who works there. She's been working there for 37 years, and so she's an expert in serving chips to people. And they go and they ask her, and she tells them that the average person eats 8 chips, and most eat between 3 and 13 chips. What does this mean? Well, we can assume that the chip eating is normally distributed. Now, it might be skewed. In fact, it probably is a little bit, but we can just assume that it's normally distributed because that's going to be a good approximation of human behavior. And she said the average person eats 8 chips. So we can say that the mean customer, the customer mean for chip eating is 8. And then she says most eat between 3 and 13. Aha, that's an approximate measure of the standard deviation. Since most people eat between 3 and 13 chips, and the average number of chips is 8, that means most people eat 8 plus or minus 5 chips. So we can say the standard deviation is 5. Now, with this information about the customer mean and the standard deviation, we can calculate the z-score for each of the 5 girls, the number of chips that they eat. So I will go up here to calculate the z-score in F4, and the formula that I want to use is our standard formula for the z-scores down here. So I'll type the Excel formula equals open parentheses, and I want it X is E5, the number of chips that Brittany that eats, E5, and I'm going to subtract from that the mean number of chips of the population. That's down here in E11. And now I want to freeze that cell because I want that to use that mean for each calculation. So I'm going to do $E $11. And that will freeze the cell for all the calculations for this whole column. I will close the parentheses, and I'll divide by the standard deviation, which is E12, and I want that frozen too, so $E $12, and I will press enter, and there we get a z-score for all 5 of the girls, going from minus 1.6 all the way up to 2.8 for Paris, who eats 22 chips. So now we've calculated a z-score for each person's number of chips. Now what we want to do is we want to calculate what percentile rank they're in, and that's the same thing as saying what percentage of the normal curve lies to the left of their z-score. And so looking at this picture, we can see how here's a Z and all this pink area is to the left. So that looks like maybe for this picture, it's about 80, 90% to the left. So Z here would be in the 80th or 90th percentile. Now to calculate how we get the percentage of the normal curve under to the left of a score, we're going to use the Excel distribution equals norm S dist, and then we put z in parentheses. And this is a normal standardized distribution function. And that will give us a fraction to the left for all of our z-scores, which will also be the same as the percentile rank of X. So over here in column G, I will type in our Excel formula equals norm S dist. Now you've got to remember to put that S in there, and then open parentheses, and then I'm going to put F5 in there for Brittany's z-score, and close parentheses. So F5 has a frame around it, showing that's what we use. I press enter, and there we get some decimals indicating what percentage lie to the left. Now that's pretty ugly, so I'm going to highlight that whole column, go to the home key, go to the number formatting over here, and I'm going to choose number, and that will give us 2 decimal points. And so now we have the fraction to the left for each person. Now let's convert that to a percentile rank. To do this, what I'm going to do is just copy the number. So I'm going to do equals G5. So that takes the number that's right next to it, and I'll press enter. That copies all those numbers over there. Now I'm going to put them into percentages. So I'm going to highlight the whole column, and I'm going to go back to the number formatting, and I will choose percentage. And that gives a percentage for each person. Now, I could have just pressed the percentage button too, but I forgot about that. That would have done it. And so now we can see what percentile everybody is in. Like Brittany's in the 5.48th percentile. Now, of course, since we're just using rough estimations for the mean and the standard deviation, we couldn't be so precise. We'd say, oh, she's in the 5th or 6th percentile. And that's how we could report that. Now, suppose we want to know the percentage of people that eat more than the person. And if we wanted to know the fraction of the normal curve that is to the right of the z-score that we have, the way that we would do that is we would use the formula 1 minus the norm S distribution of z, which gives us the area to the right, the fraction of scores that are higher than x. And the reason that this is true is because the area underneath the normal curve is always 1 when it's standardized. When we have a mean of 0 and a standard deviation of 1, which is exactly what z-scores are. So when we're dealing with the z-scores, the area under the total normal curve will always be 1. Until this happens to also give us the percentile, the percentage of scores that are above the average also. So in order to calculate the fraction to the right, I'm going to type an Excel formula equals 1 minus norm S dist, open parentheses, and our z is in F5, close parentheses, and I'll press enter. And I get some decimals there. I'm going to round them down to 2 decimal points, highlight the entire column, and I go up to what did I do? Okay, there, I highlighted the entire column, and I will press number. And there we have the fraction to the right. Now we can answer some specific questions about what each girl does about the chips. Our first question is, what percentage of people eat as many or more chips than Bree? So here we've got Bree. Her z-score was 0.6, so it'd be like over here. And the question is, what percentage eat as many or more chips than Bree? So that would be, we would look at what's to the right. So the answer is going to be equal to the fraction of people to the right of Bree. And that, whoops, I need to put a single quotation mark in there so it won't think that it's an equation there. So that equals the fraction of the people to the right of Bree. And I look over here and we get 0.27, or that's 27%. So we can write single quotation mark equals 27%. So what percentage of people eat as many or as more chips than Bree? 27%. our next question is, what percentage of people eat as many or more chips than Paris? So Paris, she doesn't eat very many chips, does she? No, she does. She eats 22, so there's not going to be a very high percentage. This is, again, is going to be the fraction of people to the right of Paris. And I need to put let me go back here and put the single quotation mark in. And so we look here and it says 0. Now, is it really 0? We better add some more decimal points to this. I'm going to highlight the whole column and add more decimal points with this button here, the increased decimal button. And there, now we've got some numbers. So that equals 0.003. So we can say that that equals 0.3%. So single quotation mark equals 0.3%. So that's the number of people that eat as many or more chips than Paris. And now we want to look at what percentage of people eat as few or fewer chips than Brittany. For that, we're going to be looking at Brittany, and we want the fraction to the left. That's the percentage that eat fewer chips than Brittany. So that would be this cell here. So that looks like 5%. So we're going to say that this equals the fraction of people to the left of Brittany, and that equals 0.05, which is 5%. So 5% of the people eat as few or fewer chips than Brittany. Now, what does that mean, since she doesn't eat 0? And you can't really eat negative number of chips unless maybe you're sick, but we're not going to go there. It basically means that we've got a ceiling effect, and approximately 5% of the people won't eat any chips at all. They'll be like Brittany and eat 0. Now, Rochelle is in what percentile of chip eaters? So Rochelle, she had 8. That turned out to be average, so that her z-score is 0. And so her percentile rank is the same as the fraction to the left, which means, since she's right in the middle, it's 50-50. So we would say that her, that equals a percentile rank of 50%, and that equals simply we can say that she's in the 50th percentile. Now, Bree is in what percentile rank of chip eaters? So we look to Bree, she eats 11, that's above average, and her percentile rank is 72%, and so we can say that equals, let's round that to 73%, 73 percentile, because that's the area, that's the fraction to the left of her of her z-score. So there, we've calculated a number of different things, assuming that the distribution of chip eating habits of people at Taco King is a normal distribution with a mean of 8 and a standard deviation of 5.